From Worldwide Technology, this is the AI Proving Ground podcast. When it comes to AI, GPUs may get the spotlight and models may get the buzz, but the real differentiator, the thing that turns isolated capability into scaled intelligence, is the network. Because in today's AI systems, a single GPU is powerful, but thousands of them working together, that's transformative. But only if they can communicate, synchronize, and move data without friction. That's why the network has quietly moved from background utility to strategic constraint. Power is scarce, GPUs are precious, but without the right connective tissue, all that capability stays fragmented. The work doesn't flow. The system never quite becomes whole. So in today's episode, we're talking with NVIDIA's Taylor Allison, who spends his time translating NVIDIA's AI architecture into something customers can actually operate, which gives him a clear line of sight into where performance depends less on the model and more on everything around it. Cisco's David Jansen, who's been working with organizations to build large-scale AI environments where power, security, and connectivity all collide. His perspective is grounded in what it takes to make thousands of GPUs behave like a single, reliable system. And WWT's Justin Van Schaik, who has extensive hands-on experience in network architecture and design with a focus on high-performance networking for AI fabrics. Together, they bring two sides of the same problem into focus: how AI capability is created and how it's sustained. So let's jump in. Okay, to the three of you gentlemen, thank you so much for joining. Justin, how are you today?
I'm doing fantastic. Loving my Arizona weather today. I hear it's snowing elsewhere.
It is, and excellent. Mr. David Jansen, how are you? Thanks for being here with us.
Hey, thank you, and thank you for having me. I'm doing awesome, and Justin, the snow's up here in Michigan, and it's super, super cold. So hopefully we're going to have a team event down in your neck of the woods.
Perfect. And last but certainly not least, Taylor Allison, how are you? Thanks for being here.
Doing great. Thanks so much. We got like a little bit of flurries here in North Carolina, enough to close schools, which is really doesn't say much at all because it's North Carolina.
Absolutely. Well, for those of you out there listening, this is not a weather forecast. We are going to be talking about AI. I'm going to start with you, David. At a recent panel, actually, we had Cisco president Jeetu Patel at a panel that WWT was hosted, and he said, quote, as it relates to AI, power is the constraint, GPU is the asset, but the network is a force multiplier. End quote. But David, just elaborate that on a little bit. Why is the network so important right now in the age of AI?
Yeah, hey, thank you. So let me just start with, I just want to acknowledge, yes, power is an issue. Power is the issue. Real estate is a problem. Thermals, cooling, weight, the whole data center facilities is a real challenge for our customers, right? So, as everything becomes more dense, GPUs, CPUs, XPUs in general, networking needs to meet that growth for connectivity. This is where the network becomes the force multiplier. The network acts as a force multiplier, enabling thousands of GPUs to operate as a single unit or a single unified system.
Yeah, absolutely.
Yeah.
Taylor,
what I've often included in there is that the GPU is like a brain cell. An individual brain cell without an actual connection to another brain cell doesn't do that much. I mean, sorry, Taylor, it's great math, but it's not going to, but when you start getting several 100,000 of them wired together, you can get some really impressive things going on. And if you have, we've all had bad tequila hangovers. The network slows down the brain cells. The GPUs don't work well. So you have to make sure that you've built something that will handle all that speed.
Well, and I'll just add too, your problem space and your solution space are also growing. The size of these models. I will say a single GPU can do a lot, but we're taking on we're taking bigger and bigger bites of the apple. So I completely agree. You need that high speed connectivity to get all those GPUs talking and synchronized, which is very important.
Can I add one more comment to that, please?
Of course. Yeah.
So Justin, you just triggered a little thought. You mentioned a single brain cell. So if I can make an analogy, like the network is sort of like the central nervous system for AI workloads so you can sort of connect and grow as you grow, meaning you can have different scalable units in modular designs. So you can go ahead and build things out like start with X and move to Y. Why is that important? there's different architectures that continue to evolve. So you have the whole scale up Ethernet, the whole scale out, and the whole scale across as far as what's happening and connecting these factories together.
Yeah, that circles right back around to the power conversation,
Yes.
or that the traditional methods for optimizing data centers and optimizing the density, the power, everything else, falls way short of what we need now to bring it into an AI space. So best practices have to be updated. We have to rethink assumptions that were always fine that are now no longer fine at all.
Yeah, David, I do want to get back to you here in a second because I want to make sure we give enough time to secure AI Factory and the solution that we have here. But Taylor, just real quick, for those that may not be familiar, why so much of this is about data flow and movement. Why is AI optimized data movement different than what we had prior to AI? Can you just articulate that a bit for us?
Absolutely. So, in AI, you kind of have two major categories of workflows, sort of the training of the models, building the model, and getting all the weights calculated through iterations of training runs. You also have inference, which is where you deploy the model and queries are directed at the model and tokens are generated and responses come to the end user. I say that because both of those fundamental categories of AI workloads are incredibly network dependent. It's really easy to see on the training side, that you have this sort of the paradigm where each of the GPUs is doing a little piece of the puzzle, and then they finish, and they all have to share what they've calculated with every other GPU. And in that scenario, you're waiting for that last GPU to finally communicate and share its results with the rest of the fabric. So you're dependent on kind of your average performance of your network, but also your worst case performance, because you can only move on to the next training step once you've finished that last piece. But it's also really important for inference as well. And I won't really kind of dive into the propeller head details here. I don't want to spend 20 minutes talking your ear off on that. But you have these sort of architectures that are becoming more dependent on storage, either in the node, but often remote storage that has to be the network comes into play when you're communicating with it. So basically, in both inference and in training, the network is vital, and it is essentially that's really where you sort of see the performance of your AI as a whole. And I'll just briefly add, kind of going back to the previous comment about the force multiplier. The thing to think about here is that, again, you mentioned you sort of have this bill of materials, and I'll go beyond the data center. I'll talk about like the facilities, the power cooling, of course, the servers, storage, networking. You have all these pieces, and networking is a smaller piece of the pie in terms of a spend perspective. But again, that's where this performance is coming from. That's where you either you have a high performance supercomputer or you don't. It's coming from the network. So that really is the key.
Yeah. And I'll let me throw into there as well that yes, you're right. The generative versus inference. Generative generally has been the highest focus because it has the most demanding set of requirements. However, the models are getting larger. Inference may not be able to reside on a single box anymore. It may have to be spread out. So then network becomes another complication in there. These are not a fixed set of complications. They're evolving as things get bigger. So much what we've done for the last 30 years in networking, we chase the bottleneck. We create a new bottleneck. We follow that one, nail it on the head. It's whack-a-mole, but on a large scale.
Justin, just to stay with you here for a second, where are those most common bottlenecks? I mean, that's obviously a major issue that's inhibiting progress with AI. Where are we seeing those bottlenecks right now?
Well, I mean, in the networks that I design, there are no bottlenecks whatsoever.
So, of course. But for those not designed by you, let's just say, for example, where are they?
I mean, it depends a lot on the exact workload, how they want to implement it. Like data gravity is very relevant. How are you using? Yes, generative. There's inference. Then there's agentic. Then there's RAG, and then there's these hybrid things, and then we have AI at the edge. How have you structured it out will actually determine where that bottleneck will live. Oftentimes, let's just assume that communication within a given box is going to be unlimited. No problem there. However, between two boxes, where's their storage? What is the latency for retrieving data from there? How much do they have to get? How chatty is it? Are there tweaks you can do in the storage space to actually move that, make the storage work faster, which then makes the network be the bottleneck. So you really have to, there is no single point, but let's just say that it's always going to be communication between the compute and the storage and the endpoint that's going to be creating something.
Yeah. If I can comment on that, please. So to the point about the models, right? Let's start there. There's a lot of variability of different models. There's vertically integrated specific models. And you have to have requirements for different types of networking and load balancing to optimize the best job completion time, right? So Justin, to your point, centralized inferencing versus distributed inferencing is going to have a different set of capabilities and requirements for the network. So bottlenecks, you have congestion. I know Justin doesn't design congestion, but in the point that it happens, you need a proper architecture that's going to yield optimal path and performance, resulting in the best job completion time. Justin, you and I have had many conversations regarding all-to-all, tail latency, and need for the network to accommodate for these different types of requirements of non-blocking, lossless, low latency. Radix matters, SerDes matters, etc. So I'll pause there.
Yeah, and we expect, I think, some of the innovations coming down the line, like Ultra Ethernet, are going to be addressing some of those well-known challenges and overhauling some things that should have been overhauled a while ago, like RDMA, selective retransmits. Things like that are very important, but they haven't been done yet. So I think a lot of these problems that we're seeing right now are going to be replaced by a whole different set of complications later on.
Yep.
But Dave, by the way, I wish I was speaking, like when you say it, it sounds really, really smart. I want you to keep on talking for me, okay?
I appreciate you, bud.
David, is the idea that are bottlenecks always going to be there? Or let's get into Cisco's Secure AI Factory. Is that smoothing it out? Or tell me how Cisco's Secure AI Factory is helping bottlenecks from the network standpoint.
Well, I think. Listen, you can't. So you need to be able to have proactive and reactive mechanisms to, as well as like visibility. So those three things, like we can get into like PFC, ECN, adaptive routing, dynamic load balancing. These are mechanisms that we built. So we've sort of taken like the high performing stuff, the high performance computing, the InfiniBand stuff, and moving these things on the Ethernet. I would argue lossless Ethernet is not a new thing. We've been doing this for a long time, but we're enhancing it, to Justin's point, as far as the Ultra Ethernet consortium that's happened from a standardization perspective. In addition to that, you mentioned the question was specifically around Secure AI Factory. So if I can just take a moment to take a step back. So if you look at what are the foundational building blocks of a factory, so you have scalable units, or pods. Those are, depending on what you're trying to build towards, your power, everything else. The foundational building blocks is a pod / scalable unit, and I can replicate multiple of those to build like an AI factory. Security needs to be infused into the fabric, into the application, into the ecosystem around that. It just can't be this bolt-on / afterthought. So we have the Cisco Secure AI Factory, which is specific to Cisco and NVIDIA, in the partnership that we have and the innovations that we're building together and delivering to market for our customers, and our customers across different vertical stacks. So we have everything from like NeoCloud to enterprise customers to hyperscalers that are part of this Secure AI Factory. And I can get into some of the how, but I don't want to lose sight of it's just not like the network compute optics, the NVIDIA software stack. It's security, as well as observability, because you can't sort of secure what you can't see, kind of thing, to where I can now have observability and I can understand, network events, security events, and tie those pieces together from a network application and security point of view.
Yeah, Taylor, you're shaking your head there.
Yeah, I just want to jump in and say, and Dave, you nailed it. I think kind of at the close of what you were saying that you've got both, whether you're an enterprise and you have like data governance regulations, things like that, or you're like a large CSP, a cloud service provider, and you have these multi-tenant environments where it's sort of inherent that you have this like zero trust kind of requirement for security. In both cases, security can't be an afterthought. And I think, from the NVIDIA perspective, we and my perspective at least, we talk a lot about Spectrum-X Ethernet and the performance. That obviously is critical, but it's almost like table stakes. It's kind of you sort of have to go beyond that. That's like it's a prerequisite for AI. But to truly deploy this stuff and operationalize it, that's where the security comes in. That's where the seamless operations, visibility, like you said, is crucial. So yeah, I think whether you're big or small, these things are all really important.
Well, I was going to say that in terms of the security, though, it is we have to rethink the entire approach. Yes, we have to actually involve it, but there's a whole new approach because it's not like you just slap a firewall in the middle of your AI, your generative AI build, and say, there you go, we're covered. The old paradigm is that there's a secure place and there's a non-secure place. And within that secure place, everything can communicate freely. However, what we have here is prompt attacks. We have ways that, we have a generative AI that is going to look for more information to figure out stuff, and it doesn't know that it can't volunteer this information. So the approach has to be a lot more than just the infrastructure, and the firewall generates a lot of traps and knowledge, and then there's a telemetry thing that reads, heuristic algorithms say, hey, look, there's a change in patterns. No. It's got to start at the workload itself, work at the model, work at all the different data points, and coordinate there. This is extraordinarily complex in a very different way than we were approaching it historically.
Well said, Justin and Taylor. If I can just add, please. So if we look at what customers are building out, there's multiple networks at play here. So you have traditional backend, sort of an air-gapped network to where you have like training that happens on the back end. You have front-end network that we've sort of been building for many, many years. This is how the users come in and access this from an inferencing perspective, management, and then high-performance storage. So security needs to be encompassing to that. And then if you look at the application layer, we now introduce this new thing called a language model. Whether it's a large language model or a small language model, we have to put, red team it, put guardrails around it. And then there's the whole supply chain of the language models as well, right? Like, I'm not going to create my own. I'm going to go to Hugging Face and sort of get, and that's what I mean by supply chain, and seeing what type of models am I bringing on-prem to sort of fine-tune to put my customer or my use case data in there.
Yeah, they very well said. The simplistic way that I've explained to customers is like, that little voice in your head that tells you shouldn't say that? Well, your AI doesn't have that little voice in its head telling you not to say these things.
Yes, correct.
So assume that it's going to be like a little toddler just blurting out what you just said recently, and won't do any fact checking unless you really get strict about it.
Exactly.
Approach it like that, and you'll probably you'll anticipate some of the mistakes you'll be making, but the mistakes will be made anyway.
Okay, Justin, I'm going to stick with you here. We just mentioned Spectrum-X Ethernet. Tell me more about how that's changing the name of the game here as we're going into 2026.
Well, I mean, first of all, Spectrum-X is awesome. I mean, what it's really done that's, Ethernet has had to evolve. Now you have the fact that we have many customers who don't want to have combinations of operating systems out there. There's, yes, there's NXOS, there's EOS, there's Junos, there's Cumulus, there's Sonic, there's, running FRR on a Linux box. I mean, there's a lot of different ways to connect it all up.
Okay, yeah, and David, you're nodding your head over there. Please feel free to add to it.
Yeah, thank you. So Justin, 100%. So when I look at this Spectrum-X, and Taylor, please correct me if I'm incorrect, Spectrum-X is NVIDIA's Ethernet architecture. Spectrum 4 is the actual Mellanox ASIC that is in the switch itself, right? So From an NVIDIA Spectrum 4 perspective, we offer operational system flexibility. So, Justin, I would say we're going to try to narrow that window down to deployment for NXOS and or Sonic to run on the N9100 platform for large-scale deployments. That's part of the NCP reference architecture. It yields a lot of capabilities, such as adaptive routing and the handshaking, to where you can do the NVIDIA stack with a Cisco operational model for NXOS and or Sonic for day 0, day 1, day 2 operations with like common ACE APIs back to the visibility piece from an end-to-end perspective. And then if you choose not to do the curated stack, you can also, like I call it, bring your own controller. So if you're like a Neo Cloud doing Sonic deployments, you can sort of bring your own type of controller because they have development staffs in-house to do that. Thoughts or comments or feedback on that?
I just want to chime in. Yeah, I think you've got it perfect, Dave. The one thing I'll say, we call ourselves NVIDIA these days. The Mellanox is the legacy, but it is the legacy that we built on. Decades of innovation with hardware and software, and I think it's so cool that NVIDIA has built this platform with SpectrumX, and we've worked with another titan in the guys of Cisco to partner on this and come up with something that is like you said, it's really powerful, it's really flexible, and I think especially with this partnership, the ability to penetrate new markets and really kind of expand our footprint with SpectrumX Ethernet is huge. So yeah, it's the work that both companies have done. I know, talking to the product managers, the engineers, architects, there's a lot of good kind of hard work and ingenuity going into this to build this platform.
Yeah, and that collaboration is crucial for another reason. Customer demand. They like, how do I put it gently? A single monolithic, single vendor approach tends to concern both CTOs and CFOs. And that exposure leads them down a path of trying to diversify. All well and good. However, all the various components of a proper AI stack have to be very tightly integrated. So you can't just grab it out of the box and make it work. So this collaboration between Cisco and NVIDIA is delivering, one, a tightly integrated stack that'll still work perfectly, and two, doesn't have the same logo on every single thing that's shipping.
Yeah, Justin, I mean, certainly lots of, incredible power here behind all of this, but let's talk, you brought up the customer. What does delivery look about? How do we operationalize all of this on behalf of clients that we all have together?
So, well, that's why we have the AI Proving Ground. The difference between marketing and sales is proof. And again, when it is a single monolithic stack, it is very often certified completely internally. NVIDIA's done a great job with the SuperPods. It is all guaranteed performance levels. Once you start changing those variables around, customers want to verify it. They want to put together all the different pieces and see how they perform in a whole new gestalt that was not what was originally designed by either one of the independent vendors. So the composable ecosystem that we have, I kind of put like the phrase "one beer short of a six-pack." So the customers have the six-pack; they're missing the plastic thingy that holds it together. What the Proving Grounds does is bind it all together in a way that you can actually say these different components, they work in a functioning, validated, verified sort of format. And you can take those numbers and use them for performance metrics. You can use them for predictive growth. You can use them for remediation. But those numbers, and I rattle off a long list of benefits, but those numbers are the critical things in both a business case and a technical case.
Yeah. Well, Justin, you've already brought up one beer short of a six-pack. You had a tequila reference earlier. Can't wait to hear what's coming from a bourbon or vodka, or pick your drink there. But David or Taylor, I'm curious from like the outside perspective, where do you see the value with something like the AI Proving Ground and what it can do for a customer to help drive all this forward? David, we can go ahead and start with you.
Taylor, you want me to go first, or would you like to go first?
I can chime in.
Go ahead.
I guess I just say okay, you guys know my title is in marketing, but I've spent some time in kind of I'll call it the real world, and getting my hands dirty with this stuff. And I think maybe this is a given to audiences listening here, but I think I just want to say it. Folks would not believe how hard it is to truly implement these sorts of things. And I don't mean that as a dig at NVIDIA's technology or anybody's technology. It's just putting different puzzle pieces together from different companies, different stacks, different APIs, different everything. When the rubber hits the road, that is always where the I hope this is okay to say, where the boys become the men, and where this sort of stuff becomes where the challenges are found and where the solutions are found, and so something like AI Proving Ground I think is vital. I talk to our customers, and they certainly know this. Like I said, so I think from my perspective, it's almost self-evident, but it's such a powerful thing. It absolutely needs to be stated. Just like testing interoperability, testing how these things come together. It's crucial.
Yeah, thank you, Taylor, and thank you, Justin. If I can just add a couple more comments, please. So this is where we prove to customers that actually show that this stuff works from a practical perspective, like the software stacks, all the drivers, all the complexity sort of delivered as an outcome, I would say, as a differentiator. Cisco and NVIDIA has been investing into the AI Proving Grounds with WWT. And if I can just give an example, so a lot of the work that we've been doing is if I can just give like a how. So we have Hyperfabric AI. This is, Cisco and NVIDIA, again, partnering to come with an outcome-based solution. So if I look at some of the value that we've done with some customer engagements, if I have GPUs that are in a 3-year depreciation cycle, right? And if I take 6 months to get like the network, the compute, the NVIDIA software stack, all of those components, if it takes me 6 months to do that, I've lost 1/6 of my investment in that 3-year amortization. So we're showing the customers a true outcome as it relates to time to value, time to first token, whatever term you want to use to go ahead and get that investment up faster.
No, absolutely. As we approach the bottom of this episode, let's talk about a little bit of the future. How can organizations kind of maintain their grasp on what's coming as it relates to the conversation we've had here today? Taylor, knowing that it's unpredictable what's going to happen in the future, whether it's further advancements into agentic or even something beyond what we're already talking about now. What's some of our advice for organizations to make sure that they're staying up to date with all of this?
Yeah, I think trusted partners are vital. People that have institutions, enterprises that have gotten their hands dirty with this stuff, and even as challenges evolve, as workflows evolve, and maybe like you said, whether it's generative, agentic, robotic, what have you. Regardless of the challenge, quantum, absolutely. You want to work with folks that have again kind of seen where we came from, and started solving these problems, and have some sense of what the future holds. And I think that's why, again, maybe this is probably a given, but Cisco and WWT are true veterans in this space. These are companies that have done this. They've gotten their hands dirty. They know these customers. They know their workloads. That's super important too. Of course, is kind of tailoring approaches to specific industries and verticals. But you have to have that background. And I think all three of our companies here today are we've talked the talk and walked the walk, and the future will always have surprises, but that's sort of how you get prepared. There's nothing truly new under the sun. And something may be a different scenario, but experience is really important to how you address this new challenge.
Yeah, and I'd like to riff off of that for a second, Taylor. So what's required a lot is agility. So the example that I'll draw is cloud. Remember the last big thing, clouds? And customers would put everything in the cloud, and then they would migrate everything back out of the cloud into the data center, and then put it all back into the cloud again. And they would realize that they had to build a very agile, flexible infrastructure to be able to migrate the workloads wherever it had to be. While we don't necessarily have a full crystal ball for our customers, we can tell them that with 100% certainty, any architectural standard will be torn down shortly. So you have to don't design yourself into a corner where that's the only choice you have. Be prepared for, I can list off a million things, but like the concept is there. Build for agility. Build for an organization that's not going to be dragging their toes for 8 to 12 years past that 3-year depreciation cycle. Be prepared in advance. That also maps into things like Cisco enterprise agreements that have specific line items for AI refresh instead of just standard data center refreshes on a different cycle. These things have to be anticipated on a procedural, operational, functional, financial, spiritual level.
David, anything to build on top of
just a couple of additional data points. While this thing is moving incredibly fast, I've never seen a market move so fast and continuous learning that I do. And I don't want to speak for Justin and the others, but I'm assuming they do this as well. I think the best thing we can do is to help our customers, help them define use cases, and not so much worry about what's coming. I mean, the use cases will drive what's coming, meaning, Justin, to your point, the refresh cycles are coming. This is not a new thing. There's this sort of accelerated, the networking life cycle. I've never seen it move so fast, 400 gig to 800 gig to 1.6T. Has direct impact on cabling infrastructure, to point about architectures. The volume of AI traffic is going to drive, the customers to sort of refresh, changing capacity alignment, etc. And then don't forget about the security aspect of it. I think customers right now are looking on where do I start kind of thing, at least in the enterprise space. Like, where do I start and how do I define these use cases and get rolling and guide them to what's sort of coming to, if it's agentic, robots, things that were mentioned earlier. So I'll just pause there for comments or feedback.
I would say, you start with the pain point. Start with the thing that's actually dysfunctional and see if you can if there's an AI case or method to address that pain. And it can be anything from, we have a call center that needs 1,000 people, it has 100 people, and wait times are too long. Well, then that's a perfect role for an agentic AI to go there, a perfect little chatbot to go back and forth, figure it out, resolve 90% of the problems before they have to get to a human being. If that's not your pain point, then why invest in a full-on call center AI? You don't need it. Where else can you look at it? So individualized.
And that's where I'm going, Justin. Yeah, exactly. Like, start with a use case. Don't show up and say I have an 8-way server. Like, you know what I mean? Like, that's not going to solve that business problem you're talking about. That's exactly what I'm referring to. Thank you.
Yeah, Taylor, any closing thoughts before we wrap this episode, or just based on what Justin and David are mentioning here?
Yeah, I think this is it's an exciting time. Like you guys said, change is so rapid. I both from a networking perspective, but holistically, talking about data centers, talking about AI factories, how the leaps and bounds that we're experiencing after the demise of Moore's law, and there's this new scaling laws that have come into play. And it's just an incredible time to be in this space and to help solve problems and help our customers get what they need. I think it's a pleasure to work with Cisco and WWT, and I look forward to seeing the fruits of this partnership.
Yeah, I have one more thought to add into there, because we can just kind of go on forever here. But we're all engineers and scientists here. And at the end of the day, apply the scientific method. The first thing you do is define the problem. And by the way, the problem is I don't have an AI. The problem is something a little more complex than that. That's where we have to take that reasoning approach, define the problem, gather information, form a hypothesis, test the hypothesis, little plug for the AI proving ground again, and then, talk about the results, move it forward that way. Approach it like methodology with a proven methodology, not with, read about an AI in an in-flight magazine. I want to buy 3 of them. We've all had that one happen.
I don't know who's reading AI or in-flight magazines much anymore. But
I just dated myself, didn't I?
You're good. So much potential out there, but as much as there is potential, as much complexity. So, Justin, I think what you said right there hits it on, right on the head of, be agile, be ready for what's coming next. So a good way to end that episode. To the 3 of you, thank you so much for taking time out of your busy schedule to join us here and talk about something that's definitely important and going to be more important as we head into the future. So thank you again.
Thanks for having me. It's awesome to part with you, Taylor and Justin. So thank you.
Yeah, likewise. Good stuff.
See you guys in the trenches.
Okay, thanks to Justin, David, and Taylor for stopping by today. The key lesson here is simple and maybe a bit uncomfortable. Intelligence doesn't emerge from components. It emerges from systems that can move data, absorb change, and stay intact under pressure. The question that lingers is whether the foundations you're laying today will bend with what comes next or quietly become the bottleneck. This episode of the AI Proving Ground podcast was co-produced by Naz Baker, Kara Kuhn, Diane Devery, and Addison Englert. Our audio and video engineer is John Knobloch. My name is Brian Felt. Thanks for listening, and we'll see you next time.